Hello, in this video we want to solve this question. Verify the Euler's theorem for the function f of x1 comma x2 equals to x1 into x2 to the power 3. This question is for the topics mathematics for economics. Now first we state the Euler's theorem. Suppose y equals to f of x1 comma x2 is a homogeneous function and the degree of homogeneity is n. I am writing this as suppose y equals to f1 comma f of x1 comma x2 is homogeneous function and the degree of homogeneity is n. Therefore, by Euler's theorem, n degree of homogeneity is n into f of x1 comma x2 equals to x1 into del of x1 comma x2 by del x1, that is x1 into the first order partial differentiation of the function with respect to x1 plus x2 into del of x1 comma x2 by del x2 plus x2 into the first order partial differentiation of the function with respect to x2. Now we have to verify this for this production function. The given function f of x1 comma x2 is x1 x2 whole cube. First, we check the degree of homogeneity of this function. Say both independent variables. What are the independent variables? x1 and x2 are changed by lambda proportion, where lambda is greater than 0. I am writing it here. Therefore, f of lambda x1 comma lambda x2 is lambda x1 into lambda x2 whole cube. This becomes lambda 1 plus 3 x1 x2 whole cube, that is lambda to the power 4 x1 x2 whole cube. Therefore, f of lambda x1 lambda x2 is lambda to the power 4 f of x1 comma x2. This shows that the given function is homogeneous of degree 4. This shows that the given function is homogeneous of degree 4. Why degree 4? Because power of lambda is 4. The power of lambda is called the degree of homogeneity. The given function is homogeneous of degree 4. Now we verify the Euler's theorem. x1 into del f of x1 comma x2 by x1 is what? x1. We differentiate x1 x2 cube with respect to x1. This is the partial differentiation. Partial differentiation means what? We differentiate x1 x2 with respect to x1 keeping x2 constant, Therefore, x1, this x1 comes here. Now we differentiate this x1, x2 to the power cube with respect to x1 keeping x2 constant, that is x2 cube, and we differentiate x1 with respect to x1 is 1. This is x1, x2 cube. Now we do this part, that is x2 into del of x1, x2 by del x2. That is, again we differentiate the function with respect to x2 keeping x1 constant. Now x2 into del of x1 comma x2 by del x2 is x2 into del of x1 x2 cube by del x2. Here we differentiate the function with respect to x2 keeping x1 constant. Therefore, this x2 comes here, then x1 is constant term. Now we differentiate x2 to the power 3. Therefore, 3 comes here, x2 into 3 minus 1. That is 3 x1 x2. This is power is 1 plus 3 minus 1. This get cancelled. This is simply 3 x1 x2 cube. Therefore, RHS right hand side equals to x1 into del of x1 comma x2 by x2 plus x2 into del of x1 comma x2 by del, this is x1, this is x2, is x1, I am putting the value here, x1 x2 cube plus 3 x1 x2 cube. This is 4 x1 x2 cube, that is 4 into f of x1 comma x2. Hence, we verified the Euler's theorem for this given function, that is 4 into f of x1 comma x2 equals to x1 del of x1 comma x2 by del x1 plus x2 into del of x1 comma x2 by del x2. Hence, we have proved that the Euler's theorem is verified for this function. I hope everybody understood the solution of this question. That's it for this video. Thank you.